Hello, everybody. My name is Andy Terrel. I'm CTO of Fashion Metric, a startup here in town who's out to help sell clothing online. And I titled my talk, All This Data on Me, and my clothes still don't fit. And just to kill the punchline, yeah, I'm fat, I know. So I want to talk a little bit about the fashion industry. And I was asked, I spent the last decade actually building out tools like what TJ just showed, and things like that. And so I said, well, I can talk about tools or I can talk about the fashion industry. And so I'm fairly new to the fashion industry. So I'll give my view as a data scientist who's kind of come on board recently. And so please don't feel offended if like the things I talk about to you are way too generalized, because I realize there's some very smart data scientists in the room. The fashion industry does not have as many smart people as you. So. Kind of where our company got started was really through hundreds of years of tailors that came over from Lithuania to Canada and ran stores that looked like this. And this is used to be, up to 1920, this is what you would do to buy clothing. You would go to one of these stores, you would have a nice grandmother, like our grandmother up there, actually the grandmother of our founder, who would come in, measure you, tell you what you should wear, give you advice. I mean, it was the whole package, right? You didn't have to think about all these thousands of clothes when you go to Kohl's or Walmart or things like that. But you would just go to the grandma and she would tell you what to wear. Today, that same industry exists, but it looks a little bit like this. And this is how, if you go to a custom tailor today and you want to look finery and look very nice. And in the past, it was everybody went to these stores so they could be kind of jagged. They kind of look, disheveled, and grandma would take care of you. Now you have a very dapper man who's dressed very well, and a nice fireplace with a boat that's going to help you feel that you can buy this clothing, and you know that it's going to fit. Never mind, it's just a styled Tommy Hilfiger or something, right? But the stick of it is, that's their website. Now, what happened? Their website went from something that looked very professional, very nice, very professional, very comforting, to this thing that I don't think I want to give my credit card to these guys. They're not going to keep it safe, okay? And so, really, it's no secret out there, 86% of the people still shop in stores. And it's changing, and we have some folks from Amazon who's even trying to change it more, and so on. Only 14% of people shop online. So the myth goes, but at the same time, retail is dropping like mad. If you watch the fashion industry, retail profits are just dropping down. And the other thing that makes the industry really afraid is while your average online rate might be 5% for a return rate, your apparel is more like 28%, and that's the good ones that actually tell you. I've heard as high as 50 from some folks. So in comes our founders, Dana and Morgan Linton. I think Morgan's here taking pictures. And so they came. So this is an Austin event, but they are from California. We won't hold it against them. So they came, and so Dana's grandmother had gone through generations of tailors, and she had a PhD in pharmacology, and Morgan had worked in sales with Sonos for a long time. So they decided to start up a store based upon the data analysis idea. And so they built a store that only used algorithmic fitting, and were able to drive down return rates to about 8%, way below industry average. Now, one thing you notice here is it says get fitted under 30 seconds, and there's a lot of diagrams and what's not. And then they learned that if you're going to run a store, you're going to make a very low amount of profit. They got a little investment from a man named Mark Cuban to turn it into a SaaS product, and now we're helping pave the way for new modern industry leaders in suits and dresses. Kind of the store of we want to have fast fashion, we want to get people in clothes quickly, we want to be able to size them without thinking about it. Mingwin can get you a suit in a day. Barring Magnolia can save you thousands of dollars on your wedding dresses. And ladies, if you ever try to measure yourself to buy a dress off eBay, you know how hard this can be. So that's where we are. We're here trying to update the fashion industry to the modern kind of world. So now to get to a little bit of the data science, and I realized that after seeing the other two talks, my talk was way too high level, but here we go. Bam, that's a model to me. All right. I've spent many years of my life working on modeling, in mathematical modeling and biological modeling and things like this. And essentially it comes down to you have some theory that goes into a box that you can talk to somebody for a long time and they'll tell you all the details, but you really don't know what the hell goes in that box, even if they publish a paper on it. And they get some inputs to predicted outputs. I think something a lot of programmers kind of can think of, even like data modeling, where I give a schema that's supposedly going to read some bits and come out with some tabular data, for example. And if you've ever actually used a database, you realize that often this is wrong even. So even in the case where you can really control everything, it's still modeling. You're still predicting what's on that disk. So here's what I call data science. So data science is this kind of viewpoint that you don't even need much of a theory. You just have enough data, right? We're going to fire all of our grad students and just have them collect data. That's what we heard the first talk, right? And so and essentially at that day, your inputs is a small bit of data and your output's the right bit of data, right? And so essentially that's what data science is. And this is how I explain it to a lot of people in the fashion industry. Like we'll mine the data, we'll learn different pieces. But that only gets you some of the way, some of the story. Because if data science works so well, why do none of my clothes fit? Why? Why do I get women's clothing all the time? Why are the online retails so bad? Why, as Jake Vanderplas points out, is he sold a garage door opener every day, even though he bought one for the last 3 months ago? Essentially, algorithms think we're this. They think we buy one thing and that we're going to want something exactly similar to that, and there's no kind of smart theories going on often. I really like the first talk, kind of get humans involved and like think about more of the human process and theory goes on. But this is essentially what the web analytics is selling the world, that, we'll buy this thing. Another thing that you see a lot is collaborative filtering. And Chris, I Googled and I found your talk on collaborative filtering. So this might be you might have created this slide, I don't know. It's collaborative filtering. People rate things and they say, I like this, I like that. You across different product lines. And then you make a nice tabular form of it, of everybody that goes back and forth and saying what they like. Nice thing about this is that whole thing's filled in. Like you get a nice rating, says, no, I'm not going to like that movie. And then the algorithm turns back to whether you like it or not. But this is more like what the world really looks like when you go on the online web. You think of millions of SKUs, millions of different pieces of clothing out there. And how many people want to wear the thing that's right next to you? Like, I mean, I don't want to wear what clothes you're wearing. Not that they're bad clothes, but I want to look different. Part of the whole point of being in the fashion industry is looking different. They have millions of users. So the big lie, I would say, of big data is that somehow this data tells you what you need to know. But really, take that collaborative filtering, you're just one small slice of that thing, and there's very, very few points that you're going to make recommendations on. To drive this point home even further, take the most common suit that one of our clients provides. It's a coat of 40R and pants of 40R because they measure weird, and then a fitted shirt. And we see here, neck is pretty good, sleeve is pretty good. We're a couple of sizes. You get down to chest, and you got 8 inches different from the people who are on one end to the other end of that Gaussian. And height, that's a whole foot a whole foot in there. Now you're telling me the guy who's 5'6" is wearing the same thing as a guy who's 7'6" in pants? Really? Okay. But that's what data often shows in what pants in the fashion industry. So fashion industry, you have a human in play who is not very good at actually knowing what they're doing. But also, other side of it is they've been doing modeling for a long time in the fashion industry. And the way they've done it is they've taken someone like Karl Lagerfeld, the famous designer from Chanel, and taken his mind and his idea of what people look like and produced clothing that sells very well and promotes the brand very well. So how do you get these guys' ideas working with their clothing on different people? And for some reason, this is the type of clothing that sells, right? So you can't only just have the data science of like what people buy, you also need to have what the fashion industry and the fashion designers actually do and how they think about this and formulating, coming back on their mindset. And so we work a lot with fashion industry to do that. So just to show how we kind of work, we help people build out a question set that's tailored to their specifics of their product. So if you're in a suit, you really care about things like your chest and your neck and your arm length and things like that. If you're in dresses, you care about the height. You know, how high is your derriere, or what's the difference between your neck and your your ankle and things like that. So we actually try to work with the clients to figure out what is it that has sensitivity on their garments to put into their sizes. And then we come up with a bunch of people's measurements. But no, so this comes from the anthropometric world. Been studied a long time, like all the different places your body grows, how it grows. And so you can use the models that have come through our academic brethren for many, many years and kind of get a very large, rich data about everybody as they've grown. And so one of my viewpoints is that domain plus data works really well. Just data without anything doesn't work very well in practice. Of course, other people are going to prove me wrong. So why not just measure yourself? A lot of people will just put on their website, here's a tape, I'm going to mail you a tape. I've even seen some fashion people like saying, oh, just get together and have a measuring party. Like you used to have Tupperware parties, we're going to have measuring parties, right? And besides conversion rates, it doesn't work for other reasons of like, where do you actually measure your chest at? If I ask 5 people in here to measure their chest, they're going to come up with 5 different places very quickly. And you have to ask, is it parallel to the floor? Are you rounding too much? Even the garments, is that chest really a 32 when it says it's a 32? Well, a 38 maybe. Your chest is a 38 and you're actually a 40 in your chest. And so even like variations in garments are very real. I've even been told by Levi's that if you get Levi's from Bangladesh versus Pakistan on the cutting floor, they're going to be a different size, right? And so the variations there are vast. And in some sense, I usually say, well, my first job was to clean up data in the fashion industry and then present it to real people. But I don't think I have to explain this too much here, but often when I tell people, yeah, if you're a master tailor, you can get in that half-inch variance. And that half-inch variance means that your long tail is going to be hit around 2 and you're going to be about done. And so a 2-inch difference is great. Now you go online, you have somebody else measure it, their variance may be 2 inches, all of a sudden you have a real error problem at 2 inches. And most people want to be within 1 inch off on the chest, for example. This is a good example. To kind of further put this into practice, I get a lot of people who says, oh, we try to build this in-house, and we do this in-house. And often you can get very close to like what people measure in pretty much any process. So it's very easy to get a different process to match to some bad other process, right? So what is the true measurement that people want? In this case, we're able to get a mean average percentage difference of like 3%, right, to predict a coat size. But it comes from a group of people doing basically self-measurements. Large retail audience who can learn to measure over the weekend. They put in our technology. Even out of that, you get 50% accuracy. And that kind of corresponds with what a lot of people are doing in the industry. And so a lot of people built these fit predictors inside their house. What we provide is come back to expert tailors, come back to those anthropometric models, and build from that, and using the same measurement data to predict off of, we're able to get something like a 98% accurate within the tolerance that the client needed. So that's kind of like, that's what we do in a nutshell, is come back, understand how the data of the body works. So just give a shout out to tools, because I am a tool guy, and I know there's some guys who, I'm not a tool, but I'm a tool guy. So all the things we've built kind of rebuilt from the ground up using the Python ecosystem, mostly through the NumFocus tool set from the data science. How many people have heard of NumFocus? Less than have heard of Anaconda. So my view, Anaconda is just the wrapping up of the things that NumFocus community has done for the last 10 years. And so we're definitely an open group that's believe in helping scientists build better tools so they can do things like the LIGO project and things like that. The other thing I would say we use a lot of is Anaconda. I spent years at Continuum helping them refine that product, and now I'm using it in the real world. The thing I would often say is like, you want to be able to install like this whole stack with one command on any computer in the world. Anaconda is your go-to. That might answer your question. Yes, you can use it on Bluemix. one other thing that kind of, and a lot of people ask me, well, how do you do this stuff in like a bigger scale, like when you're, because Anaconda is a very small thing, and you have to use big data tools, right? That's true if you want to like fan out and like coordinate all your pieces of your data. And one kind of project I have is like just looking at, like, for example, if you ask a lady, how do they figure out if a dress is going to fit or not, they usually read reviews. And they read 100 reviews and see if this thing's going to be loose or tight compared to other things. And so one thing we, kind of scrape, I've done a lot of scraping the web page, or scraping the web for lots of different pieces, but you can just come in, use Scrappy and the Python ecosystem to come into something like Kafka, which you can also use in your big data logging environment as well. Scikit-learn, you can have lots of different, once you bring ingest data into a big data system, use Anaconda tools like scikit-learn, and then throw it to a database that then can be an operational piece. And so we do use tools kind of back and forth all the way. Anaconda itself isn't like the big data solution, but it works well with all the other big approved Apache big data solutions. That went really quickly. Here's a picture of the fine folks who are building everything. We are looking for other people always. And so please talk to me if you have any questions. Yes.
So you said that the return online is very high, and I think in my shopping experience, besides size, there are other factors like the colors not matching or the fabric is different online from what it actually is. So do you think there's a way that data or technology can solve a problem like that?
Yeah, there are. There's so one thing is for certain. There's a lot of companies out there trying to solve the retail apparel return rate. What we've found is that by and far when you survey the audiences, like by far fit is the biggest thing. I mean, like usually people will come in. There's a lot of other factors, right? Like you'll come and you'll buy like 4 items just to see and return 1, or return 3 just to keep 1, for example. In the past, that was actually okay because you would come back to the store and you would have another purchase and there'd be a whole interaction there. So getting those 4 items and then sending them back, one, there's a hard time understanding why did you send those items back. Sometimes it's the thing doesn't look right, and often that's just like fixing people's websites and teaching them how to design and things like that. There are companies that show you like more patterns and like draping garments on your body and things like that. And so I don't know that I trust those yet, but they claim to have technologies that solve some of that problem. And another problem is just doing working with the clients to understand when somebody sends you something back, did they just order twice as much so they could get free shipping, or did they do it because they didn't know what fit, right? So there's also like just teaching the fashion industry how to gain data on what's actually happening with their clients and that sort of thing. So yeah, so there is a myriad of issues, but the number one, if you go talk to 10 VPs of digital, they'll all tell you that fit is their big issue right now. So.
The actual stat is 80% of returns are because of fit, 20% of returns are because of not matching the color, uncomfortable fabric, but yeah, the vast majority are all fit.
Change their mind or change their mind.
Maybe I had a question here, the bearded gentleman.
Yeah, well, first off, I'd like to talk to the big fan of Brother Friendly and people making their clothes. But I'm curious, this is slightly orthogonal to your talk, but I'm kind of curious where you all see the industry going in regards to basically on-demand clothing. So as computer vision makes it easy to basically, maybe X-ray scanner is a bit much, but to get the Microsoft Connect, for example, you could kind of take a picture and it would know your measurements and you could have it made to order like Nike shoes did with colors kind of thing.
Right, and Intel has just pumped a bunch of money in a company called Body Labs to do things like to scan your body and get back data. And what we find, well, first off, using that just as raw data is hard. Just like when we were able to get like within 3% of exactly what your body is, that doesn't mean that the clothing is going to fit you, right? Because this jacket, for example, it doesn't fit very well, and I hate it, but it's the only one I can pick up very quickly, right? And so like it's not like everyone will say your chest or your shoulders are the issue, but here, no, I've got a fat belly. It's just I'm fat, okay, yeah. So getting exactly what the fit issue in the clothing, like that's still very difficult, and that requires understanding the garments and working with the clients, like the fashion designers, to get their specifications and what's coming off of their lines and things like that. With that said, well, why not just print our clothing, right? If we can figure that out, if we can figure out how to, like, once we have all the data to actually print out a piece of clothing that actually will fit exactly where you are, I mean, there's no reason why we can't use something like a Connect plus some understanding of what your body does to actually just print out your clothing. And me being somebody who hates going to stores, I'm all for printing clothing. So as far as like where things come from, I think that in the future, I mean, if I was going to be like, you know, the 10-year futurist, I would see us downloading files from designers who could just whip up a kind of, because the way fashion designers work and the process they have to go to get clothing to you is fairly challenging, right? Even fast fashion, I think it was Neiman Marcus who made a big claim, like, oh, we can get fashion to you instead of being a 3-month process, we've got it down to 2. And it's like, all right, so you're still 2 months away from the time you see it on the runway. Why not be able to design it and be able to print it that afternoon? There's other issues in the industry like stealing designs and things like that. So they have a lot of issues to work through, but the technical details I think can be solved pretty quickly.
That's good. Yeah, the other strategy that suggests itself is image recognition.
Yeah. Yeah, and
Are you looking at yourself, because of that name, really is just solving that hard problem of the returns, regardless of strategy or the tool, whatever. And therefore, those 6 will be augmented by by image recognition people. And if so, what if you like to venture, what tool you think?
Well, I guess unpacking that a bit, right? One is the idea that image recognition is going to solve this problem. It is a tool in the toolbox, right? It is one strategy. It's not a strategy that we necessarily aren't going to use, right? Or wouldn't ever use. So we're definitely open to trying every strategy possible. It's all about, I think one of the things is there's a conversation with the industry about what they're willing to do and what's actually going to work. There's companies out there that take a picture of yourself holding a CD, and like I've seen companies put that on their website and get like a whole foot off of a person, right? And so like when that happens, like that erodes your brand. And so that part, like that strong brand relationship in the fashion industry really makes it very careful on what we can and can't do. But with that said, yeah, there's a lot of places where we can bring in, like, for example, I find an element guy, so I love draping cloths, and there's lots of papers on draping cloths on to do things like games and stuff like that. Do that for clothing as well, and we can do that sort of thing. There's whole issues on, you know, materials, like how will this material stretch on you? Like most women's pants have some form of spandex in them, so you can't, like vanity sizings are a huge deal, and so being able to actually deform that garment and things like that is a big deal.
All those are different line types.
Yep.
Are you hiring num and data line types or
Yeah.
image? I mean, that was really all I'm getting, really.
Do I hire image? Yes, we have a data scientist who I think he in his PhD was on taking pictures of nasal sprays and seeing how the spray filled out, right? And so, like, no, we definitely have image folks, we have modeling folks of different varieties.
So one of the things that you said, like 80% is because of the fit. How much information have you gathered of, you know, these fits are defined by different demographics?
Yeah.
You could have a European who are concerned about like slim fit and like, you know.
That can be enough, but that was more the body metric type.
Is it volumetric or is it more like societal?
You're talking about fit preference. Yeah, fit preference is a big part of it, and that's why being able to understand somebody's body shape and size and understand what they wear, you can actually inherently get preference from that. So if I know somebody's, I have 74 different body measurements per person, and I know they bought a size medium in this brand and they returned it, and they kept a size small, we can then calculate, hey, here's how the collar fit, here's how the chest fit, here's how the waist fit. They like a more tailored fit, and maybe that is more of a European fit, and maybe we can map that into the demographics of that person. The underlying data sets that we use is body scanning data, and when you have that for different regions of the world, we can also break out how those body shapes and sizes could vary between North America and Europe.
Yeah, and we're working with design. Like I have one designer I work with who's launched her line here in the U.S. and found out it sells and manufactures in China, and found out it sells better in China than the U.S. And so we're able to help her kind of fit with the preference of Chinese as well, who tend to be much, for lack of a better word, less curvy than the American population, and things like that. And so that in the professional kind of fit, the professional clothing kind of revolution that's going on in China is much different than it is here. It's kind of like, in some sense, they're doing what we did in the 60s of like the dress for success movement and things like that. And so demographics do matter a lot. And so.
Do you have like, influence based, or do you have like a supervised learning on that for saying that, hey, this is definitely European tagging or communication?
We have many different ways. I mean, it's a lot of ensemble methods to determine where you fit on top of in that category. Like, are you athletic or not? And that's kind of back with working with the vendor as well. Like, do you have an athletic? That one is one that comes up. Do you have an athletic clientele? Maybe we should ask a question about their athletic, whether they're athletic or not, and things like that. So, yep. Yeah, I mean, I don't like those methods too much, just because if you ask a Marine if they're fit and you ask me if I'm fit, you get two different answers that mean, and we'll both say no, and he's definitely more fit than I am.
We'll ask you if you like Duff beer.
Yeah. Very cool. I think, wait.
Any more questions?
Yeah. This is interesting. I used to work at Trunk Club, and we implemented a recommendation engine to try to figure out, suggest clothing to the stylist so that they could send them out. So I was curious, what do you, how do you store your data? Do you use like I was using a graph database to make the recommendations, and how do you avoid like a self-fulfilling prophecy where you start like boosting, like you start recommending this one shirt, and then they accept it, and then now the score goes up, right?
Yeah.
They bought it, and so do you add like some randomness to like randomly select something else? Or?
So I guess there's a couple of things there. One is like working with like the ground truth data, right? And the models, working with different models in different ways. And what you're kind of suggesting as far as like the recommendation between individuals, we don't actually do a lot of that recommendation between individuals right now, just because every system we've kind of encountered that does that gets, like you say, in local minima and things like that don't actually result in the return rates that people are looking for. But with that said, that's just one kind of piece of data out there. And so my viewpoint of this is, one is like try to find studies and surveys and do your own surveys that actually get you to a better ground truth of data. And you have to treat your online process as almost every day being like, well, is it true today or not, right? And just reevaluate constantly. So, and as far as like what we use on the back end, I actually use mostly just a lot of SQL and Mongo and Redis type things. So I haven't really gone down the path of graph databases too much.
It's a lot of fun with this, because I was doing this there, so bringing the graph database into the equation like made it a lot of fun.
Yeah, I'd love to hear your experience.
Yeah.
So, cool. All right, thank you very much.